I'm going to be doing number 1, and I'm Elena Chow. So as you can see, this is a piecewise function, so I'm going to try to find the different functions in here. So the first one is a parabola, and this is a closed dot, so x is going to be, it's going to be greater than or equal to -2, and then this is going to be less than, it's going to be less than -3. Okay, and we have x squared, and then 2 less than 2x -3. And for the next one, this is a line, and I'm going to find the slope of counting the rise over run. So it's rising 1, 2, run 1, 1, 2, 1. So the slope is going to be 2x, and here these are both open dots, so x is going to be greater than -3 but less than 2. Okay, and the next one right here is a parabola, and that's going to be x squared. It's suddenly blurry. Yeah, and then these are both open dots, so x is going to be greater than 2, less than 4. And here, this is optional. I'm just going to do it anyways. I don't need it to solve the question. This is going to be -2 for the f of x because this is a line, and these are both closed dots, so x is going to be greater than or equal to 4, and it's going to be less than or equal to 6. So we have -2, and then we have 4. Perfect. And now it's asking if the limit of the limit as x approaches to 2 of f of x exists. So I'm going to do that by looking at 2 from the left and to the right. Let's start with 2 the left. So the limit as x approaches 2 from the left of, and in order to find my equation, I have to look at the inequality here to see what applies to 2 from the left. And looking at my graph, 2 from the left is going to be this line right here. So from the line, that one is going to be 2x, so there. And then I'm going to plug the 2 into the x. So it's going to be 2 equals 4. So now I'm going to do the same with the other side. The limit as x approaches 2 from the right. And from the right, as you can see, it's the parabola. So it's going to be x squared equals, I'm going to plug this in, so it's going to be 2 equals 4. As you can see, both equal 4, so the limit does exist. And finally, the limit as x approaches 2 of f of x exists if and only if the limit as x approaches 2 from the left of 2 of x equals the limit as x approaches 2 from the right of x squared.
Hi, my name is Sean Chi, and this is my APCalc group assessment. And this is question 2, in which it asks if this piecewise function, g of x, is continuous at the point x equals 3. And to do that, there's 3 steps. So 1 is to see if g of c exists, c being the internal point. And to do that, we just have to look at where x equals 3. And so x is greater than or equal to 3, which means it also equals. So then we substitute 3 into the corresponding equation. So g of 3 equals natural log 3 minus 2 plus 2. And that then turns into natural log of 1 plus 2. And the natural log of 1 actually equals 0. So that would just be 0 plus 2. And so g of 3 equals 2. Then our next step would be to see if the limit of g of x while approaching c even exists. And to see that, we need to see if when approaching c from both sides, the limits equal each other. So the limit approaching g of x from the left side, we would use this top equation. So g of 3 equals square root x plus 1. Substitute that in, plus 1 all over square root. That would be 4, which then equals 2. So then g of 3 equals 2, approaching from the left side. And then we already know that when using this equation, approaching from the right side, g of 3 equals 2. So then finally, when approaching g of x from the left side equals 2, and then approaching from the right side equals 2. So our limit equals 2. And then when approaching from both sides, now it equals 2. So then our last step would be to see if this limit of g of x is equals our step number 1, which is g of c. And earlier we saw that g of c equals 2, and 2 equal 2. So therefore, g of x is continuous at x equals 3.
I'm Ashton Chang, and I'm going to be doing number 3. So in order to solve this problem, you have to apply the intermediate value theorem to it. And in order to do that, you have to check for 2 conditions. A, if the function is continuous, and B, if the interval they give you is a closed interval. So we can already see that, yes, h of x is a continuous function, so we have that checked off. And the interval is also closed since it has brackets around it. So we can already say that, yes, h of c will equal 0, or there will be a value that will equal 0 between these 2 intervals. And you can also imagine this by also graphing it. So if I were to make a quick sketch of it, so if I were to graph the points that they give us, so 2, -3 should be right here, and 4, 2 here. So it's saying that is there a value for c, basically an x value, between these 2 points where it could equal 0. And yes, because these points have to be connected in some way or another, and that line that passes through them has to pass through c0. So in the end, we can say that yes, there is a value c on the interval that exists because the function is continuous on the closed interval of 2, 4.
I'm Taylor Carroll. I'm doing number 4 of this group project, and my question is, what is the limit as x approaches 1 of f of x times g of x? And the product rule states that you can write this as the limit as x approaches 1 of f of x times the limit as x approaches 1 of g of x. And because these are jump discontinuities, we have to find it from both the left and from the right side of both graphs. So starting with the left side, you can see that as it approaches 1, it also approaches 1 on the y-axis. So the limit as x approaches 1 from the left of f of x equals 1. And for the g of x, you can see as x approaches 1 from the left, you can see it approaches 3. So the limit as x approaches 1 from the left of g of x equals 3. Then you multiply these together and you get 3. And for the right, you can see as x approaches 1, it approaches 3. So the limit as x approaches 1 from the right of f of x, it approaches 3. And the limit as x approaches 1 from the right of g of x, you can see it approaches 1. So 1. Then you multiply these together and you get 3. And so since they are the same, they have the same limit. And this means that the limit as x approaches 1 of f of x times g of x equals